Hello there, hope you're having a great day. And as you probably recall from your integral calculus days, a very common type of application problem with calculus is with regards to position, velocity, and acceleration. And that's no exception in 3D. In fact, this is why calculus was discovered in the first place. Isaac Newton was trying to figure out the motion of the planets, including their velocity, acceleration, and their position. And he had to discover calculus to make all those connections. So that's where it comes from, a very common application, and we're going to talk about it in 3 space. And what I'd like to do in this lesson is just give a basic overview of it, and then the next lesson we'll do an example. And we'll give you this question. So if r of t represents the position of a particle at time t, so it's our position function, what do you suppose v of t, the absolute value of v of t, and a of t represent? So let's go ahead and check out a table to look at this. So we have our description column, we got our vector function we're going to put here, and our derivative and integral forms of that vector function in these other columns. So let's just write down what we're given. We're given r of t as the position function, and we want to classify v of t and a of t, which we'll put as these other vector functions. Now we know that v of t is going to be the derivative of our position function r of t. And just like in 2D, this represents the velocity. And the fundamental theorem of calculus tells us that if v of t is the derivative of r of t, then r of t must be the integral of v of t. So let's go ahead and fill that in. And as you might imagine, a of t is the derivative of our velocity function, v of t. So just like in 2D, this is going to represent the acceleration. And again, the fundamental theorem of calculus tells us that if a of t is the derivative of v of t, then v of t is the integral of a of t. So let's go ahead and fill that in too. And that other question about the magnitude of v, well, that velocity function is going to have a direction in it, but if we just want to look at the magnitude of it, that's just going to give us our speed. So that magnitude of v is our speed. And that's our basic framework for position, velocity, and acceleration in 3D. And if you stay tuned, in the next video we'll go ahead and apply this framework with an example application problem. So see you then.